leaf plots, the first thing we're going to talk about is bar graphs. This is one way to look at a set of data and compare it, because it represents the different quantities that you're comparing. You can easily see different categories. For an example 1, we've got animals and how fast they can run. So we've got cheetahs, wildebeest, lion, elk, and zebra. And how fast they can run in miles per hour on the right. Miles per hour is a unit rate. So how many hours in a miles per hour? 1 hour in a miles per hour. Okay, for those of you who are looking at the proportions and stuff. Okay, so this table shows our speeds over here. And we're going to make a bar graph which represents this data, 70, 50, 50, 45, 40 over here. And when we make a bar graph, you don't have done this before. So we're going to make bars, our categories go on the bottom, and our numbers go on the left. And for cheetah, how fast? 70. So we're going to make a bar all the way to the top. Now, the important thing about a bar graph, is a cheetah the same thing as a wildebeest? No. Is it even close to being a wildebeest? No. So we have to make sure that our bars are separate. Okay? Touching bars means that there's some kind of a relationship between the two things. Okay? So we don't want our bars to touch when we're doing a bar graph. A wildebeest goes 50, so we're going to make a bar for the wildebeest up to 50, correct? Yes. Okay? Same way with lion, elk, and zebra, your bars have to be separate. So for lion, we'll also go to 50. The elk goes to 45. How do we figure out where to put the top of our bars? Yes.
In between the 40 and 50.
In between the 40 and the 50, and we have to estimate about where the top of that's going to go. With 45, probably about in the middle, right? So we'll draw a line kind of in the middle between 45 and 50, down to the elk. And then last is the zebra, and he goes 40. Comparatively, right? But he can run faster than you can.
Yeah, it looks like the AT&T bars.
Yeah, like the AT&T bars. There you go. Yeah. Okay, so let's review here. Quiet, please. We've got our categories. We've got our categories on the bottom. Our numbers are on the y-axis. Remember, the y-axis goes up and down. The x-axis goes left and right, like a number line. And then our bars have to be separate because we have separate categories down here that don't have anything to do with each other. Cheetah is its own animal, wildebeest is its own animal, lion is its own animal. So the bars are separate. Any questions? Why is this bar graph better to look at than, say, doing a line plot like we did the other day, where we had our number line? We would have had a number line and we would have put X's above the numbers for... There you go. What was that? How would you label it? How would you label a line plot like this if you're trying to compare the two animals? Very good question.
Put it under the number.
You would have to put it like with the number. We've got two 50s here, so we have to put wildebeest and lion. Would it kind of start to get confusing using this line plot? Yes. Okay, is it easy to see on the bar graph how to compare the speeds of two different animals?
Why don't we just use a bar graph?
Okay, so that was the question. Why is a bar graph better? Because it's easier to compare the different animals if we use a bar graph versus a line plot where we're not sure. We have to write all kinds of information down below. Okay. So here's another example of a bar graph. And this time we are going to interpret our bar graph. So we've got monthly tornadoes in 2004 in the United States. Notice our categories are once again on the bottom. That's your months. And then our numbers are once again on the y-axis. That's the number of tornadoes. Okay, so which month had the least number of tornadoes? January, because it's the closest to zero, right? Very good. January is closest to zero. So January had the least number of tornadoes. Which month had the most? May. And we can see that that has the tallest bar. So we know that has the most number of tornadoes. It includes Oklahoma, but yeah, it's the middle part of the country, the Midwest. Okay. That would be kind of a science lesson talking about why there's more tornadoes in the Midwest. Okay, ask your science teacher. Okay. All right. So, let me ask you a question about this graph. What's the difference between the number of tornadoes in September and the number of tornadoes in April? How many more in September than April?
150.
Okay, we have to approximate, right? Because we don't get an exact number here for April. What do you think this one is worth?
125.
Maybe 120? 125? Okay, and what's this one worth?
300.
300. So what is, how many more in September than March?
275.
About
270. No. 170.
175. Okay, so about 175 difference. So that's interpreting the bar graphs. Do y'all have any questions about those bar graphs?
No.
Okay, you've seen those before. Now we're going to talk about a special kind of bar graph, and that's called a histogram. When you look at this histogram, what's different between this and a bar graph?
They're all together.
They're touching. Why are they touching? Take a look at that picture and tell me why you think. Why do you think, Hope?
Because like the numbers are all like back to back. It's 11 to 20, then it's 21 to 30.
Very good. So take a look at the numbers below the bars. Notice that the first bar is 11 to 20, and the second bar starts with 21. Those numbers are right next to each other, correct? So our bars go right next to each other. So in a histogram, we have intervals that go along the bottom. And an interval is a set of numbers, 11 to 20, 21 to 30, 31 to 40, 41 to 50, 51 to 60, 61 to 70, all in a row. We put our intervals on the bottom in a histogram, and on the left side we're putting frequency, how often something happens. Okay, frequency, how often something happens. So, in this histogram, we've got speed on the left now in intervals, and the number of animals that can run within that speed. So 5 animals run between 11 and 20 miles per hour. 5 animals run between 21 and 30 miles per hour. How many animals did they use for this data? How many animals did they look at?
30.
What was that?
30.
30. So how did you figure that out? You counted up all this, right? So 5 animals, 10, 8, 0, and 2. That makes a total of 30 animals. Okay? If you need to know how many things you're looking at in a histogram, you're going to count up the frequency. If this table wasn't here, we'd come over to the histogram and say, okay, this one's 5, and this one's 5, and this one is 10, and this one is, what does that look like, 8, okay? And then we're going to add up the frequencies to find out how many animals there are, okay? So we already noticed that one of the differences between a histogram and a bar graph is that the bars are touching in a histogram. So go ahead and write that down. Bars are touching. And what is something similar to a bar graph? Yes.
They both have bars on them.
Okay, the bars. They both have bars.
Where's German?
Okay. Are there any other similarities or differences that you would think of between a bar graph and a histogram?
Numbers in the left, numbers and labels in the bottom.
Numbers on the left? Labels on, or categories on the bottom, right? This time our category isn't a word though. Our category is a number. It's not just one number though. It's a what? An interval. Okay. So our category here is an interval instead of a label or a name. Okay. So let's take a little bit more of a look at how we can graph a histogram. So what goes on the bottom of the histogram again?
The intervals.
The intervals, right? Okay? Yeah, categories or intervals goes on the bottom. So on this histogram here, I want you to go ahead and write in your intervals, 7.0 to 7.4, and then move over a little bit. Notice that it picks up right with 7.5 as if we were counting. And 7.9 ends and 8.0 picks up the next one. And the intervals are all the same. There's 5 numbers in every interval. Okay? So your intervals should be equal intervals when you're making a histogram. You shouldn't say 1 to 10, and then 11 to 40, and then 51 to 60. Okay, those would not be equal intervals. Your intervals should be equal. Okay, and then on the left-hand side, we're going to put what?
Frequency.
Frequency of, what are we looking at here?
Magnitude.
Frequency of magnitude. Okay, what is this along the bottom, this interval?
Magnitude.
This is magnitude. So let's put magnitude down here. Magnitude is how strong an earthquake is. Okay, and they put it on a scale of 1 to usually, I don't know, with earthquakes. Is it 10? Is it 1 to 10? Scale of 1 to 10 for earthquakes. Okay, it's the Richter scale, right? Okay, so this is magnitude along the bottom, and this is the frequency of the magnitude. Okay, I'm just going to put abbreviations here. And since we're going from 1 to 14 in our frequency, what should we count by on our y-axis? 2s? Okay, 2 sounds good. Let's count by 2s. So 2, 4, 6. Okay, when you're doing your y-axis, it has to be an even interval. Just like the bottom has to be even intervals, the side also has to be even. Now we can make our histograms. So I want you to go ahead and draw in your bars, and remember they have to touch this time. Your bars have to touch. Okay, you should end up with a histogram similar to the one that's up here. Okay? All right, why would it not be a good idea to color everything the same color? All your bars. They all look the same, and if you've got 2 or 3 intervals down here that are the same number, they kind of all run together. It's hard to tell where one starts and stops. Not that that's important, but it just, in looks, it looks better when you're presenting something to have all your bars be different colors. Okay? So there's some real world application. All right, now, on number 5, the histogram shows the number of stores in the largest malls in the U.S. How many malls are present in the histogram? Do you remember what I said you had to do when you're trying to find how many? You add all the bars on the histogram. Okay, so if we're trying to find how many malls we're looking at here, we're going to add the value of all the bars.
30.
30? Okay, so 30 malls are represented here. So we're going to add 10 plus 14 plus 4 plus 2 Well, 1 plus 1. How many malls have less than 200 stores?
1. 24.
Which bar
10.
represents
10.
less than 200?
10. There's 10.
Okay, and which bar did you look at? The first one, 125 through 199. So there's 10 there. 10 have less than 200 stores. How many have more than 200? 200 or more. Sorry.
40. 0.
Okay, 20. The rest of them. Very good, Kylie. So 20 have 200 or more. Y'all have any questions so far? Okay. We're getting there now. Last thing that we're going to look at today is the stem and leaf plot. Okay, stem and leaf plot. That's what we're going to look at. All right. So, in your stem and leaf, you're going to take a table of data like this. This kind of reminds me of the mean, median, mode, range tables that we looked at a little bit ago. What is that, Monday? We looked at it. Okay, so in this one, we're going to make a stem and leaf where we have like a T chart. And on the left-hand side of the T is the stem. And on the stem, we count by what?
1.
It's not really ones. Tens. Very good, Stephen. We count by tens. So here's the single-digit numbers. They start with 0. Then we have our 10s and our 20s and our 30s that go along for the stem side. On the leaf side, we have the ones place, right? So the stem side has the tens place. The leaf side has the ones place.
So why do you say 1, 2? That's by 1.
Okay, so let's take a look at this. So when we have the number 19, we can see it on the stem and leaf plot here. The tens place is a 1, and the ones place is a 9. There's the 19.
Oh.
Okay, when we have the number 7, the tens place is a 0, and the ones place is a 7. So there's the number 7. Okay? When we're looking for the number 21, the tens place is a 2, and the ones place is a 1. Now you see there's 2 ones here. We must have 2 21s in our table. There they are. Okay? So if you have a number that doubles up on the one side, that means you have more than one of them in your data over here.
Wait, if there's 3 2s, then there's like...
How many 12s do I have?
3.
3 12s. I have a 10 place and 1, 2, 3 2s places. So there's 3 12s right there.
Well, why is there a 0 that you... Oh, 20.
20, right. 0 means it's a 20. And this 0 means this is 10. So I have, what's my mode here? What's the one that shows up most often?
2. 12.
12. The 10's place plus the 3 2s. That's 12 shows up 3 times. How many times does 11 show up?
2. 3 times. No. Oh, 11? 2.
2, right here. Here's a 1 and a 1, a 1 and a 1. 2 11s. 10's place, 1's place. Very good. Okay, so now we're going to create one of our own. So for our stems, we have to write down what?
1, 2, 3, 4, 5.
We're going to start with 0, though, in case there are single-digit numbers, right? So let's start with 0. 1,
7.
2. How far do I have to go? To 7?
Go to 8. Just in case.
You could go to 8 just in case if you want to. Okay, so there's our 10s places. Now let's plot out our 1s places. So 42. I'm going to cross that number out, and I'm going to come over here on my stem and leaf. Actually, you know, that would kind of be hard. Since we want our 1s to be in order over here, let's find all our single-digit numbers. Where are they up here? What have I got for single digits?
0 and 5.
I've got 0 and 5. How do I write a 0 in the leaf side?
Don't. You write 0.
You just write a 0 on the leaf side. Double 0. Okay, if you don't put a 0 there, then it's like there's no 0 in the table because all of our numbers need to be represented on the leaf side. Okay? So we have to put a double 0 to represent this 0. And then we'll put the 5 to represent our 0, 5 number. Okay? Our single digits. Now, 10s. Do we have any 10s?
No.
Across those other two. Do we have any 20s?
24.
24?
That's it.
23. Which one's going to come first? 23, so we'll put a 3 and then a 4. Okay, cross those two out. How about 30s places?
There's a 30, there's a 35.
so I've got two 45s, a 42 and a 47.
No, there's 3 45s.
No, there's
That's
one
a 45
42.
and a 49.
And there's 345.
Okay. All right, so let's put these in. We need a 42 first, and then 3 5s to represent our 3 45s, and then a 47 and 49. Everybody with me so far?
No, I'm lost. Oh, now you lost.
Okay. All right.
Let me go.
Let's follow along with me and write them down.
There's 60. There's still 60s.
Okay, so this is the tens place. So you're trying to make all these numbers.
Hello.
Okay, so our 50s. What do we got for 50s? We got a 51,
55, 56, and 58.
55, 56, 58. So I have 1, 5, 6, 8 for my ones places next to my 50 spot. Any 60s? And 70s we have
2
5s. Okay. Okay. So, what is the range? How do we find the range?
Take the lowest minus the highest.
What's our highest number?
75.
75. What's our lowest number?
0.
0. We got this 0 right here on the leaf side. So 0 is our lowest number, so our range is 75. Is there a mode?
Yes.
What is it?
45.
45. 3 5s in a row right here. That's 4 in the 10 spot and 5 in the 1s. 45. The median, you're going to count back from the middle. Okay? So for the median, if you wanted to mark on your numbers, you could count back from the middle, from the ends, and get back to the middle. What'd you get? 45? Okay, so when you get back to the middle, you'll have a 5 left. Let's look at interpreting one of these. What's the most, in example 7, what's the most common amount of pasta that was consumed?
15.
Right here, all these 5s in a row, that's your mode, and the 10s place is a 1. So correct, 15 pounds. Thank you. It is a word problem.
Good job.
What is the range of the amount of pasta? Okay, so what's our highest number?
59.
59 minus the lowest number, which was 3, and that's 56 pounds. Okay. All right, so I am going to hand out your